Alright, on this. So number one you guys did yesterday, but since I'm doing this as an answer key, I would jump back and do it later on again. So you guys can hear all those explanations and stuff in there if you want to. If not, you don't have to watch that part of the video. But we're going to go on and move on to number two. Okay? Number two says, hold on. That probably ain't showing up good.
Woo! Now it has a glare on it. Still, it still has a glare. Oh! It's still got a glare. Or maybe it's just when I'm sitting. No, it looks like a glare. I don't really see a glare.
I don't see a glare really.
I guess it's just where I'm sitting.
Oh, I see it on the
Wait.
camera, but I don't see it in person.
That's what I'm here.
Oh.
I thought you meant like on the board. I was like, I don't see it.
No.
I'm so
It
sorry.
just matters on the It's still there. It's not really bad, but it's still there.
Thanks. It was from Walmart for $12. They have like several different colors. They have
Oh, it's
better ones
fine.
that are like brown and it has like this.
I guess it's
like
just where
thing.
I'm sitting.
And those ones are 20. But this
It's
one
your reference angle. You're seeing the glare actually on the back of the lens. It's not part of the actual video.
Oh. Okay, then I see it on the entire head because I'm
It's also soft.
right.
I don't like
Yep.
this.
I'd rather have
Alright, so in this, number two, if you have three books that are stacked on top of each other, with the top book having a weight of 122.1345 newtons. So we got this top book. I'm going to make a big book. You have a middle book. It has a weight of 99.2772 newtons, and the bottom book. So we got a middle book. Then we have a bottom book.
a table.
Having a weight of 85.1508 newtons. What are the normal forces acting on the top, middle, bottom books, and on the table? They are all stacked on.
It's okay, it's not English.
That's right. So then we have a table. Alright, so in this is what you need to start looking at and thinking about. In this case, there's two ways to really solve this problem. So the first case you're going to look at is in every one of these are free body diagrams. Okay, every one of these have a force of gravity.
Michael Klein, Desiree Kennedy, Braxton Walls, please come to the office.
I'm just calling this force of gravity 1. Here's force of gravity 2. Here's force of gravity 3. And in every one of these cases, every time you're looking at this, remember what the force of gravity is. It's just weight, which I gave you.
Oh, varsity cheer practice is canceled today.
So in this, that force of gravity 1, you go to 122.1345 newtons. That force of gravity 2 is equal to 99.2772 newtons. Force of gravity 3 is equal to 85.1508 newtons. Alright? Now here's the key. I kind of already gave you an answer on one of these. The key to this is remembering what is the normal force. The normal force is literally parallel to the surface, and it's opposite of the force of gravity.
So
So normal forces are looking like that. Question.
So would that be
Well, you can make a choice. Do we want negative as up or negative to be down? In this case, think about your normal forces. Where are the normal forces going to be pointed at?
It's going to be pointed up.
All normal forces are going to be pointing up. So do we want up as positive or negative?
Positive?
That's fine. It doesn't matter if you want to make it positive or if you want to make it negative. So
Well,
this case,
if you make up positive, is your answer going to be positive?
yeah, because normal forces are pointing up. Therefore, we're going to end up with positive answers because we made up as positive. And that means down is negative. So in this case, we need to find the normal force. So you got the normal force of 1, normal force of 2, normal force of 3, and then the last one, you have the normal force of the table. I'm going to put T for table. I know it's hard to see, but
T.
there's my diagram. This is why I love using the Elmo. It just zooms everything in. It doesn't matter how small I write it. You can zoom that bad boy in and see it. So zoom back out. Now in this, I've set you up. This problem is not meant to be very complex and solving. It's meant to make depth and thought. So in this case, whenever you're looking at this, what is the normal force of 1 equal to?
Negative force of gravity.
Negative force of gravity of 1. Because that's the only thing pushing down on that book. So what we have going on here is these forces of gravity is where we're going to have to take it into account. And every one of them is going to be negative because we made down negative. So now those forces of gravity are negative. Now this case, the normal force for the first book, the top book, is 122.1345 newtons. Now this is where it gets different, and this is why you have to have that thought process taking place here. The normal force for system 2 is equal to the opposite
Negative force of gravity.
force of gravity 2, but you also
The
have
negative force. You also have the force of gravity of 1, right?
the force of gravity of 1.
That's what I forgot to do.
Because the force of gravity of 1, this book's still pushing down on it. That mass has to still be accounted for, so that's what we're doing here. Okay, and look, so that nobody's like freaking out on me here. That's a different color.
So each time you go lower, you have to add those to that.
Yeah, because those are stacked on top of it. Like when we get to the table here, it's going to be all of them together.
Okay.
So in this, realize we got this negative sign out front here because it's the opposite of all of these added together, these forces added together. These forces are negative, so it'll give me a negative number, and a negative in front of it will make it a positive, which is what we should get because up is positive. So in this case, I'm going to add force of gravity 1 plus force of gravity 2 to give me 221.411
Paige Taylor, come to the office. You're signing out.
newtons. Alright?
And then you, for the next one, you would add the force of gravity 2 and 1 and three together.
Exactly. So force.
Cassandra Bailey, come to the office.
In this case, is opposite force of gravity 1 plus force of gravity 2 plus force of gravity 3.
So it doesn't matter what order we put the force of gravity in your book because I'll put it backwards like you did on the second one.
No, it don't matter. You're still adding these together.
Okay, I get that now.
So 251.1508. Add those together, and I get 306.5625 newtons. Oh man, that's a horrible man. Newton. There we go.
I did not get that. For the third.
What'd you get?
negative 428.697. But I did my directions opposite of yours. But it should still be the same answer, shouldn't it? Oh,
Yeah.
I think I know. I only added 120. I didn't add 220.
Okay. As long as you get there though.
And then now I just add all those together.
He give you force on the table.
Yes.
Normal force on the table. But here's the key. Normal force on the table is still right here at the end of that bullet. It's literally that right there.
Wait, what? Oh. Oh, just because I get it now.
Because they're just sitting on the table.
Oh.
So they'll be the same. Questions?
Can you kind of explain more in depth why the table is the same as F and Drew's?
What's on the table?
All the books, yeah. Okay.
That's why. It's because this accounts for all the books here.
Okay.
It takes care of everything in there for us because when you get to the table, there's no mass being added to it.
Yeah.
You're still just looking at the same amount of mass that you're dealing with. If that helps.
Yeah. It does. Thank you.
Yeah, you can go ahead.
Close what?
All right. Questions on 2? Moving to 3. So if a sprinter has a mass of 78.56 kilograms, so in this case, I'm going to start writing information down. Mass equals 78.56 kilograms. It has a velocity of 1.56 meters per second. So I have a velocity.
I think it would be initial velocity. Because, and like the final velocity would be 0 because we're trying to stop.
Because I know what the question's going to say, yes, it's absolutely, this will end up being the initial velocity because of that scenario you just said. That's exactly what you're looking at. Because before they try to stop sprinting, so that's the initial velocity, that's how fast they're traveling before they try to stop sprinting. If it took the sprinter, I'm going to add a final velocity, it is 0 meters per second. If it took the sprinter 0.748 seconds, 0.748 seconds to stop, what was the force applied by the runner to stop sprinting? This one is this is one of those that's like that mid-level question I'll give you to try and assess like your knowledge in this case, if that makes sense. Like this isn't the hard problem I'll give you, but you could look at something about this level. I expect you to spend maybe 5 to 10 minutes on and figure this thing out. Because what you'll end up getting is force equals mass times acceleration. Well, we got a problem.
We need acceleration.
We need acceleration. So in this case, we're going to have to find that acceleration first.
Haley Kennedy, come to the office.
Acceleration.
So we would use one of those 3 problems.
One of the 3 formulas. Which one you want to jump for?
That's 9th grade. Haley Kennedy, come to the office.
I think we should use the. I remember it as VOTAT, but it's final velocity equals initial velocity plus acceleration times time.
So in this, you'll get acceleration equals final velocity minus initial velocity.
If I could have your attention, please. Mr. Stewart wanted me to make everyone aware that due to the storm, which has downed several trees throughout the county, we can expect significant delays with transporting students home from school this afternoon. So they're letting parents know that people might be late. We need to make sure that all of our teachers on bus duty are also aware of this.
So that would end up being a negative. Like the thinking of the differences in the velocity.
Oh yeah, I got that backwards. Sorry, I'm getting caught up on what they're saying. Alright, so final velocity is 0 minus 1.56 meters per second divided by time, which is 0.748 seconds. And this will end up being the negative, like you said. Look at you. You said you got no idea what's going on.
Well, now that I'm actually sitting down and thinking about it
Look at that.
and going through it.
So I get a negative, I'm going to write it down here so I got room to write 2.0856 meters per second squared. That's the acceleration I get. And it makes sense for that to be negative. Why? Because right now I have my initial velocity being positive. So in that case, these have to oppose each other. Because if acceleration does not oppose the initial velocity, then it's not going to stop it, it will speed it up. So then we can go back over here now and figure out that force equals mass, which is 78.56 kilograms, times acceleration, which we saw to be negative 2.0856 meters per second squared, to get negative 163.8417 newtons.
Is
So
that
that's
the
our
same
answer.
thing?
Yeah, that's the answer. What was it, sorry, Kat?
Is that the same thing kind of for force like it is acceleration? It's got to oppose itself or
Yes.
each other?
It has to oppose. Because think about it, like what force, if the force was going in the direction of motion, then it's going to speed him up. It's kind of like when cars hit each other. So if you got a car that's kind of like just barely strolling, and then somebody rear ends that car, that force was applied in the direction of motion, so it makes the car speed up and go forward faster.
Alright.
Any other questions there on 3? No questions on 3. You guys will love 4. 4 is a trick question.
Are you really looking for anything on 4, or are you just multiplying it times 1.26?
Did anybody in here answer number 4 without doing any math whatsoever?
Without doing any math?
Without any math.
No.
No.
On the surface of planet X, the gravitational field is
Is it the same thing
1.26
as
times that on Earth. What is the mass of a 22.5 kilogram weight on planet X?
Is it 22.5?
It's still going to have the same mass.
Is that the same mass?
I almost cried over this.
Kilogram is a unit of what? Mass.
That's funny.
Oh my, I think
Wow.
I did math at first, and then I realized
I,
Mass does not change whether you're in outer space, you're on Earth.
mass.
Doesn't matter what planet you're on. Mass does not change. Weight changes.
So that was your trick.
See, my stupid hind end was thinking he meant weight, but it's actually a weight that you carry.
No, listen, me and Katie argued for literally 10 minutes.
It was so funny.
This is the key. Let the unit be the key for you. Okay? Kilogram is mass. And listen, tomorrow, if you have any questions on this quiz, ask me. In a case like that, if you looked at me and you said, Mr. Hall, like, you got weight here, do you mean like the weight, like a force of weight? I'd be like, no, I mean like a weight, like what a power lifter lifts with.
Yeah, Katie. This is how you know I'm not going to pass this test tomorrow.
You got
Riley Costello to the office.
Oh, what for?
All right. Number 5 is also
I'm waiting.
a little bit of a trick here. that you really need to think on. If you haven't realized, I'm trying to give you stuff like this. I'm trying to pull and see your knowledge on this. I want you to be able to think through this. So, Jack Bauer jumped into a helicopter that has a mass of 4,568.35 kilograms. Does Jack Bauer have anything to do with this?
No.
Oh, that is there to confuse you. Only thing you're caring about is right here. That mass. So in this, what we're caring of is the mass. He's being chased by some Russians. I felt like saying he's being rushed around by some Russians. But
He should have.
Okay, we don't care about the Russian weight.
Daniel, will you come to the office?
and is needing to know the acceleration of the helicopter he is in. So, he's needing to know the acceleration of the helicopter we're in. We have now found our questions, ladies and gentlemen. Well, just ladies today. What is the acceleration of the helicopter if the force of the helicopter upward is 50,000 newtons? Y'all ready for this?
Is it says upward. So
here's the thing.
is it gravity?
Gravity has a play in this. You guys, like I was really hoping you guys would catch this real quick.
Well, we didn't.
Free body diagram. What forces are going on here on that helicopter?
It's going upward now.
Hold on, I heard two things and I was coughing at the same time. One more time.
Gravity's pulling it down.
Okay, got force of gravity coming down.
And the acceleration, the
Force
forces
pulling
pulling
it
it
up.
up.
And then you have, I'm going to say the force of the helicopter. That's making it go up. In this case, if you want to find the acceleration of that helicopter, you're going to need net force.
Is that the F1 plus F2 plus
The
F3?
summation of the forces within the system. So we're going to need force of the helicopter plus force of gravity. Why? Because from there, we know the mass of the helicopter and we can work backwards, find the acceleration. So in this case, you were given the force of the helicopter. That's 50,000 newtons. But we don't know the force of gravity. But can you solve for it?
Yes. Force of gravity equals the negative version and wait. No.
Force of gravity, mass times gravity, which your mass is 4,568.35 kilograms, times gravity, which is 9.81 meters per second squared. Kilogram times meters per second squared gives me newtons, which is good. That's what we're looking for. So I throw out my calculator. 4,568.35 times 9.81 equals 815.5135 newtons. Now here comes the thing. And you need to choose what's going to be positive and what's going to be negative.
Yeah, I was thinking like that.
What are we going to make positive? Up or down?
I guess up.
I like up. I'm happy y'all said up. It's a great movie.
So make your gravity negative.
So that makes gravity be negative. Because the gravity, acceleration of gravity will be negative. So we have negative 44,815.5135 newtons. So in this case, we can now find net force, which is equal to 50,000 newtons plus negative 44,815.5135 newtons.
She was like, did you go for that?
get 5,184.4865 newtons.
Is that our answer? Wait, no, you have to find acceleration.
Gotta find acceleration. We have the net force now. So from this, we can now find the acceleration. Because the net force is equal to mass times acceleration. So acceleration is equal to the net force divided by mass, which is 5,184.4865 newtons divided by the mass, which is 4,568.35 kilograms. Newtons divided by kilograms gives me meters per second squared. So I will end up with,
Can you scoot it down a little bit?
alright, 4,568.35. I get 1.1349 meters per second squared.
And that's our answer.
And there's the answer.
What I don't get is why net force is just completely tripping me out. Why
Net
is
force.
it-
Net force is literally, it's like the force that's actually happening, the overall force. So it's kind of like you can have multiple forces acting on something at one time. But then all those forces, they're going to cancel each other out or add up, and it's going to result in a resultant force.
Why have we never had to do the F1 plus F2 before? Did we have to do that on number 2?
So like all
Yeah,
these
Brad.
problems are like a mixture of pretty much hard, easy,
So
tricky.
that's all that was. It's just
And mediocre problems.
Mediocre.
Yeah.
And they use like everything. Your net force, the ones where you don't even have to do math, the ones where you need to like kind of know what you do.
He's a wizard.
Now in this case on number 4, if I was trying to find the weight
Then it would be
of that weight, then you would do the math that a lot of y'all probably did. You would take 9.81, which is Earth's gravity, times 1.26, get that number, then multiply it by 22.5 kilograms.
yeah.
Not hard. Are any questions here? And really, that's all that net force is it's literally just a summation of everything.
So
Of all
Ninth
forces.
grade, Madison Hatfield, come to the
all
office.
Can you kind of like
Forces
briefly
add together.
re-explain that to me real quick? Because they called me in the office. Like just briefly gather your thoughts process real quick.
What two forces are acting? Force of gravity and force of the helicopter. So in that, if I'm trying to find the acceleration of the helicopter upward, if I'm going to do that, I have to know the net force. Because once I get that net force, which you get here, it gives you that overall, that's the force that's actually acting on. That's the force that's pushing the helicopter up. So you can work backwards to find acceleration equals net force divided by mass, put the net force in, divide by mass, and it gives you your acceleration.
Thank you.
Well,
This is all about knowing your formulas, like, to me.
knowing formulas and pulling information apart.
Yeah, and then like if you're missing something from that formula, do the formula to get that one, and then it's just
Formula.
formulas.
All right. You guys are good there. I'm going to jump on there and do number 1. Now, I'm pretty sure everybody in here's got one, but I'm going to roll through it. Just so it's in the video.
Yeah.
All right. You have a car that is driven by a stunt driver. This stunt driver is trying to jump a ramp with a mass of 1,487.76 kilogram car. So, Put my black pen. Good pen. Mass is 1,487.76 kilograms. If this car is trying to make a jump of 150 meters and their velocity when they leave the ramp is 11.56 meters per second, so velocity is 11.56 meters per second, and it took a total of 9.58 seconds, so I'm going to call that time 1. To reach that velocity, what is the force acting on the car pushing it forward? Will the car make the jump if it is in the air for 3.457 seconds? And that'll be time 2. So in this, I'm going to deal with the first question. What is the force acting on the car pushing it forward? Force is equal to mass times acceleration. I have the mass, I do not have the acceleration, so I need to find the acceleration. In this case, refer back to the simplistic definition of acceleration.
Change in velocity or change in weight.
Yep. But in this case, understand you're not finding a change between these two times. This time 2 is for scenario 2. This time 1 is for scenario 1. Heard you raise questions when I did that. So this right here is what I'm looking at right now, because this is the case I'm looking at, the force that is acting on the car pushing it forward. When's the car being accelerated? Why it's on the ground? How does a car accelerate? You give it gas, it turns the wheels, it pushes the car forward. Okay, you'll learn about friction and all that here later on. So it's going to push this car forward from there. Once it leaves the ramp, is that car accelerating? No. So in this, when we're trying to find the change in velocity, that would make this velocity the final velocity, because that's what I leave.
Madison Hatfield, come to the office.
That is what I leave the ramp with. So I have final velocity, which is 11.56 meters per second, minus the initial velocity. I didn't list it up here, but what's the initial velocity?
0.
0. I mean, that's what the car's going to start with. Divided by change in time, which I told you is right here, that 9.58 seconds. So whenever you do that, you find
1.2067.
1.20, what was it,
6-7 meters.
6.7 meters per second squared. Okay, so now we got the acceleration. So now we can work back and get force. So force is equal to mass times acceleration. In this case, our mass is 1,487.76 kilograms times acceleration we just solved for, which is 1.2067 meters per second squared, which will be equal to
1,795.27.
Oh, it's
8.
this is what I get because I
1,795.27.
I get 1,795.25
Oh, 25.
on 1 newtons. This is why I get that. I just took that big long decimal. I just saved it. That's why you guys retype that in. For those of you that got that 0.27 right, that's what you guys got.
0.2799.
For those of you that got that, you're still fine. I'm not going to count off on that because you just typed something back in the calculator. I didn't. That's why we got the subtle difference. Okay? So there's the first answer. So now, will the car make the jump if it was in the air for 3.457 seconds? This is foreshadowing stuff that is to come. So in this, I'm literally going to do this. I'm going to solve for a final position As if
It wasn't there.
I had no clue what it was.
That's what I did.
And it works perfect. It's a beautiful plan. I'm going to keep working on this. You guys can leave, but I'm going to finish this so that I can upload this video for you guys to refer to. If you have questions, please message me on Remind. Okay?
Alright.
And do drive careful. Okay? Drive safely. Alright, so as you are leaving class, the key to this is we now have a change that's been made in this scenario. This now becomes my initial velocity, because that's what I left the lamp with. You'll find out in things that come, this is how this problem is foreshadowing. This is all being dealt with in the X direction, and that velocity doesn't change until it hits the ground. So we're looking at it. We're going to try and find that final position. In this case, the initial position is going to be 0, because we would make initial position 0 meters and final position 150 meters. But we're not going to use that. We're going to solve for it and see if it'll get to that 150 mark. If it'll reach that 150 mark, then the stunt driver was successful. If not, then it's been an epic fail for him. Within this, acceleration will have to be equal to 0. You're fine, you come in, I'm going to finish this real quick. Meters per second squared. In that case, that makes this 0. Since that's 0, all I'm really left with is the final position is equal to the initial velocity times time. This makes sense because when the car leaves the ramp, can the car accelerate? No, the car can't accelerate. All it can do is just keep flying with the velocity it had. So in this case, the initial velocity of 11.56 meters per second times time, which is time 2 in this case. We're not going to use that time 1 there. We're going to use that time 2. 3.457 seconds. Seconds cancels, leaving me with meters, which is what I want. So 11.56 times 3.457 equals 39.9629 meters. So does he make it? No. Epic fail. Wasn't even close. If you have questions, message me on Remind. I will see you all tomorrow.